Hello everyone. Today I want to show you how you can conduct a simple linear regression. So simple linear regression, as you know, that is different from the correlation test. So you have the independent variable and have a one dependent variable. So you can find how much the independent variable affects the dependent variable. In the correlation test, you will know only there is a relationship between two variables. There is no distinction between independent and dependent variable. But in the regression test, you will know that x, that is a independent variable, how much that is affecting the yx, the dependent variable. So we have here the data set that is asking about the satisfaction of the job, and then we want to proceed with the regression test, how the burnout affects the satisfaction in job. So when you go to the variable view, you have here the satisfaction, and also you have the burnout. So these two variables are, you can see that is a continuous variable. So for the regression test, we have an assumption, many assumptions, but one of them is that two variables should be continuous variables. Okay, so here we have this satisfaction is a dependent variable and the burnout is an independent variable. So how burnout is affecting the job satisfaction, this is what we want to know. So you can go to the analyze, and here is now regression and then linear. Okay, and I already put the variable here. So the satisfaction should be dependent variable, and the burnout should be the independent variable. When you click the statistics, you will click the model fit and the estimate, and that is for the statistics. Okay, you can continue. In the plot, we want to know about the assumption test, about how they are homogeneously distributed according to the independent variable and dependent variable. So you can put this appropriately. And then also we want to know the errors are properly distributed in this graph. So you can check the histogram and then normal probability plot, and then continue. And in the save, you will go to check the unstandardized. And then if you want to know the predicted points in the individual scores, you can check also individual. So for the moment, this is all we can do. And then now you click the OK. So with these options, in fact, I chose the stepwise. So that means that that is the what is the significant. We can I mean the machine chooses the stepwise the what is significant. But in fact, this one is we don't need to worry about this because we have only one independent variable. So about this stepwise option or other method that will be important in when we conduct the multiple regressions. So this is a simple linear regression, so you don't need to worry about that. And then in the model summary, you can see that R. So that is that indicates that the slope. So how much is significant. So normally that is between the 0 and then 1. So this means that that is a significant level of slope. So adjusted R-square is more like in reality this will be the more possible to happen, and the R-square, that is the squared number of the 0.4 here. So that means that if exercise, how that can be happen, how much that is accounted for the to explain the dependent variable. So this one we have to consider as the effect size. And in the ANOVA table, you can see that that is F value, and then that is significant. So F value means that the multiple regression line that is very close to the individual scores. So between the line and the individual scores, there are not many big differences. So there are not many errors. So that's why F value is significant. And in the coefficient, you can find that that is the unstandardized B and the standardized beta. So standardized beta is the same value with the R value. So you will consider them as the same way. And then this one is not standardized, but this the number can be used when you write the formula of the regression. So that and then constant means that that is on the when x is 0 in the y-axis, that is where they start in the y-axis. So the t-value also that shows the slope. So in here the burnout, the slope is significant. So that means that the slope is not a horizontal way with the x-axis. It's more it's a big difference between the x-axis and then the regression model line. Okay, and then we have the chart here. So that is normally distributed, and also the individual scores are not very far away from the line. And then this one, you can double click, and then you will put the line, and then close. And you can see that is a homogeneity in the regression. So that is distributed, normally distributed. Yeah, so this is all about the plot. So with this, we can consider that the burnout is affecting significantly the job satisfaction, and you can report the F value, and then also the coefficient is a T value, and then also you can report the R and the R square, that is as an effect size. So this is all about the simple linear regression. Thank you.